My name is Jordan Scott. I'm a regional sales manager with TerraSource. I will be giving the presentation for the Nanosiz-R and certainly appreciate your attendance for this webinar. Kind of as an introduction to the Nanosiz-R, some comments here. The Nanosiz-R is a single-stage roll mill. It's compact, affordable, and epitomized for making 1 to 2 millimeter product. The single-stage high-tonnage roll mill can crush up to 40 tons per hour. 2 roll mills in stages produce 19 millimeter feeds in a 4-to-1 reduction stage to 1600 micron product. The first, or the primary Nanosiz-R, takes the 19 millimeters to 5 millimeters, while the secondary crusher takes the 5 millimeters and reduces it to 1600 micron. Rolls are constructed of alloyed iron, and heavy-duty steel construction make the Nanosiz-R extremely reliable. Robust 18-inch diameter rolls are based on Gundlach's roll mill technology. The Nanosiz-R is ideal for fine grinding applications such as mixing limestone with coal to reduce the sulfur content of emissions, and certainly several applications in the fertilizer industry, potash, phosphate, nitrogen. In addition to this information, the Gundlach roll mill produces less dust and generates less noise compared to other crushers in its class. The Nanosiz-R is an affordable crusher in its size range, lower capital and energy costs than many other technologies. One of the real values is multiple units in series can achieve greater reduction ratios with accuracy in thousandths of an inch. I guess at this point I'd like to mention, as you can see, this is a fairly small footprint, which has real advantages. Fits in small places. And to give you an idea, the height on an Nanosiz-R is approximately 39 inches, length 85 inches, and that's kind of common through the series of Nanosiz-Rs from a 4020S to a 4060S. Weight would be between 10,500 pounds to 16,000 pounds. And just to give you an idea, you keep on hearing the footprint advantages of this piece of equipment. Giving you a couple specs here I think is helpful. Again, going back to what I mentioned previously, due to its modular design, multiple units can be used in series to achieve greater reduction ratios. Perfect for making 1 millimeter product distribution for a fluidized red bed boiler sorbent limestone. Now, I'd like to make an attempt to go over some of the specific equipment that is on the Nanosiz-R. As you see right here, this is the adjustable bearing assembly. Where I have this is the adjustable roll assembly. Again, as you would assume, this is again the base frame. Go into here, this is the housing seal assembly. Bounce up here, the stationary roll assembly. We have here the bearing assembly adjustable. Going into here where certainly the rolls are. You've got some of the vertical liners, end liners, port inspection. So an idea of some of the parts to the piece of equipment there. Again, here is a better view, a couple of the things I mentioned. Inspection port, the end liners. To give you an idea, these are adjustable, ultra-high molecular weight end liners, excellent for abrasion resistant, low friction, no moisture absorption, corrosion resistant. Going to the corrugated rolls, 18-inch diameter chilled iron, 600 Brunel hardness, which we can offer various tooth profiles, chisel, segmented, herringbone, smooth. Again, these are the adjustable vertical liners which offer a closed fit to roll elements. Again, these rolls we get from Spain, poured from a hard alloy surface followed by gray iron core, to assure a long roller life. Depending on the material and the maintenance, some of the rolls get up to 4 years of life. This is kind of an example of how you want to introduce the product into the rolls. Again, you've probably heard this from some of our equipment. It's not necessary to have a 2-meter drop, but it certainly has some value to create some velocity as the material is entering a piece of equipment. Another tremendously important point is even dispersal over the entire roll length, which of course will certainly lengthen the life of the roll. Adjusting wedge block is part of the piece of equipment. Adjustable roll holding cylinder. Here are the housing seals. Again, our air purge seals aid in preventing dust escape. Mechanical seals preventing leakage, containing pressure, and excluding contamination. We use a dual bulkhead lube system, which are 2 bulkheads, contain all lubrication points on front of the crusher for easy access. Grease lines are hydraulic hose, not plastic. I do apologize for lack of a picture here. This is a picture of the Nanosiz-R test plant in Belleville, Illinois. Like all the equipment that we have for our testing is things that you can certainly use in the field. This gives you a pretty good idea of a nano. Again, a typical V-belt drive guard system. This wouldn't necessarily be just the limestone. The units are a little bit off, but gives you an idea on the different capacities, the short tons per hour, respective motor horsepowers that would be used, and the product size that you can get. Again, as mentioned before, limit to the capacity on this equipment is approximately 40 short tons per hour, going down to anywhere from actually 10 to 5 tons per hour. Again, here are some of the advantages of the Nanosiz-R. Important to understand that the Nanosiz-R utilizes a bimodal size reduction via shear and compression. The shearing mode is achieved by the use of differential speeds, which is the adjustable roll operating at a lower RPM than the stationary roll. And going back to the point that 19 millimeters or 3/4 inch is the maximum feed size, and getting down to 1 to 2 millimeter product size if necessary. Comparatively speaking, the Nanosiz-R is low capital, energy costs on existing technologies. Part of the lower power consumption is the motor horsepower is not wasted on generating fines. In many applications, the Nanosiz-R's horsepower requirements might be close to half that of a hammer mill. Smaller footprint, which we have already discussed and you've seen. Using the modal system, multiple units in series can achieve great reduction ratios. This equipment does become important. One-piece chilled iron rolls at 500 to 530 Brinell with alloy steel shafts pressed into ends. Sectionalized housing where you have vertical removal, which is a value, especially from a maintenance standpoint. As mentioned, heavy-duty fab steel base. Housing with the dust ports. Again, plate liners. Seals at the house shaft opening. Spherical roller bearings. And these bearing housings with compound seals. Again, things mentioned previously. The bulkhead lube system, the roll speeds, secondary roll speeds. With the faster roll, you certainly have higher horsepower. With the slower roll, lower horsepower. Again, going back to feed and product size, primary and the secondary. And some of the notes that have some import to it. Original rolls can be rebuilt as many as 5 times before needing replacement. This is an important fact since the rolls can be around $25,000 new. Again, the rebuild consists of grinding the rolls down so they are again smooth. Again, rolls starting at 18-inch diameter can be ground until they get to 17-inch diameter. Working roll surface hardness about 3/4 inch deep. Integral shafts press into roll heads and machine concentric to roll body. Make-up air ports on housing used when air is drawn out of the discharge area under the crusher. Is sized to allow about 3,000 to 4,000 CFM of airflow. And depending on what one may need, quoted as an available option. Anybody has any specific questions? More than happy to entertain that and see if I can answer them.
I've got a question. Can you hear me?
A little bit, yes.
Okay.
And this is who?
Steve Bernard.
Okay.
How about pet coke granule gradations for basically primary reduction cathodes on a standard aluminum plant?
And what are we talking about from feed size? Is that fitting the sizes that we?
Feed size, they always get it in less than 3/4 of an inch, but they prepare it. They basically dry it and prepare it. Sometimes they even calcine it at the plant.
Right.
Where they will size grind the coke in different graduations and put it in different bins. So when they make the anode and they press the anode together, it'll have a certain percentage of minus, say, 1/8 inch, and a certain percentage of minus 1/16 inch, and it depends. It depends on what the makeup is on the anode.
Okay, right.
And they use it on the liner material also, but basically they have to prep the pet coke and size it, and then put it into bins so that they can proportion it to make an anode.
It'd be a good opportunity for us. You bring up something that's good that should have been that I can quickly discuss now. I mean, obviously, a couple of the slides you do see pet coke being involved. Primarily, what we've used this piece of equipment on to date has been, again, fertilizer, some limestone and salt, but primarily fertilizer. But pet coke would be a fine material for this piece of equipment. So to answer your question, we'd certainly be happy to evaluate pet coke and probably do some testing on the material you might have.
Extremely abrasive.
Well, and then you've come to a point that's well taken. Abrasion and hardness are issues for the Nano because of the roll. Mm-hmm. Hardness is somewhat obvious. Abrasion, kind of on a one-to-one basis, but that does become an issue in a circumstance for any of the material that we deal with. I'll give an example that I had 9 months ago. Somebody come in with garnet and was trying to extract the walsenite that was on the material. He had never seen the type of end product that we produced. But, on a Mohs scale, garnet's about 6 or 7, walsenite's worse. And we told him, unfortunately, because the guy was begging for us to sell something to him, we said, well, your rolls will probably last you 2 or 3 weeks. Mm-hmm. He was still sitting there trying to figure out how this might work, because the end product, we were getting like 98% passing. Mm-hmm. But it was a material that would have not made sense for us to sell something. So I guess the bottom line is we would look at the material. A small portion could be sent, or we would pursue a test to see if it would make sense. But abrasion is a challenge in a circumstance.
Okay, well, garnet, we have a garnet producer in our area also, but they take it down to below like 165 mesh.
Okay, that would not be us. So, yeah. The mesh size is where it starts not making sense is smaller than 18 mesh, 20 mesh.
Mm-hmm. Okay, well, thanks.
Okay, well, and thank you. Good question.
Okie doke.
The question from Mr. Young is in the process of development. What kind of materials have been used to crush tests, such as coal or rock? How long have the tests been done continuously? And so I'm clear. Again, the material to date that we've had quite a bit of success with the Nanosiz-R has been fertilizer, salt, certain fairly highly calcinated limestones. Those have been the materials that we've had the most success with, but we do certainly have other minerals that we're more than happy and capable of testing. Again, the last question was productive in the sense that we do have limits on the material that we can use because of the type of roll we used. Certain material that we can easily handle in a roll crusher, for example, we simply cannot due to the type of specialized roll that we have. Material that that's hard and abrasive is not a good fit for the Nanosiz-R. And to date, that's probably nothing that's going to change. But things that look like they may have a possibility, we are always happy to accept the material and do some testing. I guess to give you an idea of how long some of the tests have been going on, 10, 12 plus years. Any other questions? I don't see any on the Q&A. I guess I would have a question if anybody out there, is there anybody that has a prospective or potential salt application? Yes or no? But
what kind of application?
Salt.
Oh.
We see there's a lot of room for growth depending on the capacities and, again, the feed size to use this piece of equipment with salt, either as a primary, secondary, or even tertiary, because that's where we've seen a lot of growth in the specific potash markets up in Canada.
Jordan, are you looking at that, Doug Crone, APA, are you looking at that as
Hey, Doug.
Hi, how you doing?
Doing good.
As a better piece of equipment than maybe what they're currently doing, or more from just the aspect of an expansion or an upgrade to an area?
Well, it depends. If you're trying to reduce fines, which becomes one of the reasons why someone would buy this piece of equipment, let's say you are competing with, a hammer mill, and I would say even one of our cage packers. And again, TerraSource makes both hammer mills and cage packers, so it's not that we don't like selling those pieces of equipment. It just depends on what you're looking for. Here are some of the advantages. Let me pluck this out of the air. Some of the advantages that the Nanosiz-R does have over a hammer mill. It operates at a much lower rotational speed, RPM, than some other reduction equipment, hammer mills. A hammer mill, as most of you know, may operate at 1,000 RPM or higher. Typical Nanosiz-R will be between 150 and 300. One aspect of this, outside of what type of material you can produce, is that it reduces roll wear, and again, in the reduction of fine generation, more of the product is produced in the target size range, better yield, plant balance, and again, the lower power consumption, which for many is very important, is the motor horsepower is not wasted on generating fines. I've mentioned this before, but some of the Nanosiz-R horsepower requirements are half of a hammer mill. So there are some advantages comparatively to other equipment, but you would buy this for the reduction of fines and your end product. It does make a great end product for the materials that are applicable. Again, the challenges I see with this equipment is not what it can produce, but handling the type of materials, handling the type of materials that people would like to test. I will admit that we are fairly defined on the kind of materials as we speak that we can utilize this equipment with. I think that's just an honest appraisal. It's not for everyone, but I do believe there's expansion with some materials we've already done some testing, and also some minerals that we really haven't. Again, friable, fairly highly calcinated, not very abrasive materials are, good things for us to use this equipment with. Okay.
Well, thank you.
Appreciate everybody's participation.